So let's take a look at a proof by contradiction A-level question. And in this question, we need to prove that root 3 is irrational. Well, firstly, let's assume it is rational, which would mean that we would be able to write root 3 as a over b, where a and b have no common factors other than 1. That was if root 3 was rational. So let's go ahead and rewrite this. So we've got root 3 then equal to a over b. If we square both sides then, to get rid of the square root, we're going to end up with 3 equaling a squared over b squared, which means 3b squared equals a squared. Now, if a squared equals 3b squared, we know then that a squared must be a multiple of 3. As we can see, it's 3b squared. If a squared is a multiple of 3, that also means that a must be a multiple of 3. Now, if a is a multiple of 3, we can write it as a equaling 3n, where n is any integer, and we know if we multiply any integer by 3, we're going to get a multiple of 3. So we can write a equals 3n. Let's plug this back into the formula. 3b squared equals a squared. So we get 3b squared equals 3n squared. So if we square that out, we're going to end up with 3b squared equals 9n squared, which means b squared equals 3n squared. Now, if b squared equals 3n squared, we know b squared must be a multiple of 3, which means then b also must be a multiple of 3. If we take a look at our first assumption, we were saying that root 3, if it was rational, we'd be able to write it as a over b, where a and b have no common factors other than 1. But clearly here, if a and b are both a multiple of 3, they're going to have a common factor of 3. So therefore, the assumption is wrong, and root 3 must be irrational. This is how we would go about proving by contradiction that a square root is an irrational number.